So you bring up that term dark API. You said that as one of the things you want to talk about. I've never heard that term before. What does that actually mean? And then we can go into like what you're actually talking about with CUDA dark API.
Yeah, it's a pain. So something you should understand. So CUDA obviously not an open source API, but there's something more to it. Is that your code is always a second-class citizen on CUDA platform. You may not realize it, and I will explain why. So first thing, there's really 2.5 APIs on CUDA. So there's two APIs most CUDA engineers will be aware of. There's what they call runtime API and driver API, and they're extremely similar. Runtime API is slightly higher level, driver API is slightly lower level. We implement driver API. And there's also one more API hidden from a public view. So we have API. Typically, if you have API, you have a name of a function, number and type and name of the parameters and the return values and some documentation. With Dark API, you have nothing. Every function that is supported by Dark API is some kind of unique identifier, git, and the index. So you ask your runtime, you ask your CUDA driver, hey, give me table with function pointers for this unique key, and this is used by Intel runtime, really for no good reason. I don't know why they do this, and for some first-party libraries, because there's some things Nvidia doesn't want you to know and be able, or they don't want you to be able to do. And a classic example is ray tracing. So if you look at, so you might think, okay, I have my GPU and I want to know if my GPU is capable of hardware ray tracing. And CUDA doesn't expose this information, at least doesn't expose it to you. It exposes this information to its own libraries, its own runtime, and it goes through this hidden API. It has no name, has no documentation, so we call it dark API. I don't know what is its proper name. It's nobody knows. And the dark API is frustrating experience for someone for something like Zluda, because we have to implement it. It's actually almost killed Zluda, because first time I'm enabling very simple application, just adds it adds two numbers. All it does adds two numbers on the GPU. So I have this good application, and I look at the interactions between application and CUDA driver, and everything goes as expected. Every function that I wrote in the source code is being called, and there's one small addition I did not write, and there's call to this Q export table, and I look at it. It's some kind of unique key I never seen before, and this gives me a table of pointers. I don't know what are those pointers. Okay, I set breakpoint on each one of them, and it calls one of them with, for some reason, I know no arguments. I don't know what this function does. I decided that's too much for me. It's too much for me. I give up, and I gave up for, I don't remember, for 2 weeks. And after 2 weeks, I thought, well, okay, maybe, well, I'm in mood for some pain. Let's try it. It's probably not going to work. And I look at this function. Actually, look at what function it calls, and it's 4 instructions. It calls allocation. It calls malloc to allocate some memory and returns this memory to the driver. Okay, I thought, well, it's not so bad. Actually, and it's really motivated me to keep going, and pure luck, because it was by far the simplest and easiest function from Dark API. All other ones have been slightly more difficult. And generally, so generally, I don't And it was wrong approach to look at what this function does, because it's most of the time it's not super useful. Nowadays, what I do, I look what are the inputs and what are the outputs, because usually that's your first clue. If a function returns some kind of pointer, and you see across the rest of the application that this pointer is used as context, then you know, okay, this dark API is creating context with some internal bits being set or unset. And those bits are not really important. We might as well create a context for Zluda, because it probably does something, but there's no, across the applications we had, there's no observable effect to this function that is different from the public API. So that's how it goes. And we implemented those only parts of Dark API that are necessary to run your applications, mainly interactions between the high-level runtime API and driver API. Runtime API doesn't always talk to driver API through the public APIs. It also talks through Dark API. And then I noticed that the first-party libraries use Dark API for various reasons, which I don't care about.
So it's basically just those internal functions that there's no point for them to document, because you're never actually supposed to call them yourself.
I mean, I think they should document them.
Well, they should,
because it would be nice to to use to know how can I use everything that I paid with this GPU, but they decided not to. There might be some thinking why they do this. I mean, it's obfuscation. Maybe some of those things they just don't think are useful. Maybe some things they just want to hide. Well, when it comes to ray tracing, they definitely want to hide those things, because optics also doesn't expose those things.
Whatever the reason for it, it makes your life a lot more complex.
Yeah. It probably makes also life of good engineers more complex, because some things they do in this dark API, I don't know why they are doing this. It's just, for example, there's something they added recently, and my suspicion is they wanted to make my life more difficult, but compiler optimized out all they wanted to do in this function, because this function, what does it do? You have, let's call this function foobar, and it returns if function foobar, so itself, starts at an even or odd byte in memory.
Okay.
And this is completely totally pointless, because your compiler will pretty much always align your function to not only to even address, but most likely to your natural size, to 64 bits. So it's always going to return 0. I don't know why they do this. It's just mystery to me. And literally 2 instructions, or 3.
I don't know. I don't. I have an answer for you either.
But my expectation is there was more complex body inside they wanted me to implement, but optimize everything out. Who knows what they are thinking? It's mystery. I only care about applications running, not about their creative ideas.
Right. So with these dark API functions, the way you're basically approaching them is effectively like a test suite, where you're throwing data into it, you're looking at the data that comes out of it, and you're hoping that whatever you're doing in between is getting you the result that would happen on an actual Nvidia GPU with CUDA.